Okay, I'm going to use decimals to plot this data here. And time is going to be the independent and distance is going to be the dependent. So for example, it's going to be 6. And instead of using 50, I'm going to divide all the distance values by 100 just so that it looks nicer on my graph. So it'll be 0.5. At 12, it'll be 1. At 18.3, it'll be 1.5. And at 25.2, it'll be 2. Actually, maybe it will look a little bit nicer because the x values are getting a lot bigger than compared to the. So I'm gonna make it actually divide by 10 instead of 100. Okay. So I'm gonna go back and multiply all of these y values by 10. So you get 0.5, you get 10, you get 15, and you get 20.22. Okay. So here's the graph. Okay, I'm gonna just pull this graph now. Okay, so we have it here. Determine the equation of the line of best fits. Okay, so it looks like it's something like that, right? So we can assume that it passes through, what is it? This one here was the 18.3, right? So it passes through that. So that's one of the points. Okay, and then another one, perhaps it passes through the point before. So it passes through this one. So 12 and 100. So with those 2 points, we can get the slope. The delta y is 150 minus 100 of delta x. The change in x is 18.3 minus 12. So it's 50 over 6.3. Okay, so that gives me 7.94. So our equation is y, or the distance, is equal to 7.94 time plus the initial value, the initial distance. To get that, we need to plug in one of these points. I'm going to plug this in here. So when d is 100, t is 12. So d0 is going to be 100 minus 7.94 times by 12. So the initial distance is 4.72. So our equation is 7.94 t plus 4.72. Okay. So what is Thomas's time for 175? When distance is 175, this is part B. What is the time? Okay, let's do a little algebra to isolate t. First of all, subtract both sides by 4.72. So t will be 175 minus 4.72 divided by 7.94. 21.4 seconds. Okay, seconds. That's part B. Is it reasonable to use the same line of best fit to determine the time needed to run 3,000 meters? Okay, so that's not reasonable, right? Because a person will get, as this distance, as time goes, right? So they're running at a certain speed right now, certain meters per second right now. And you can certainly do that in the first 40 meters, right? First 30, 40, even 100 meters. But 3 kilometers, 4 kilometers, you're gonna get tired. So this line is not realistic. Over time, it's probably gonna slow down, right? Because a person will get tired, right? So that's the answer for part C. What does the slope of the line of best fit tell you about Thomas's run? Well, it's speed. So the speed we got was 7.94. That means Thomas runs 7.94, right, meters per 1 second.